Metal clangs, sparks flash, and in less time than it takes to choose a laundry cycle, raw steel and plastic parts come together into the comforting hum of your washing machine. Curious how that transformation happens? Let's step into the factory where blades of metal become something that cleans your clothes and your life. Before a washing machine hums to life in your laundry room, its journey begins in a very different world, a place of noise, heat, and precision. This is the realm of raw materials, where the future washer is still just steel, plastic, and aluminum waiting to be transformed. It all starts with sheet steel, huge coils of it, sometimes zinc-coated to resist rust, other times pure stainless steel for the more premium inner tubs. These coils arrive at the factory in massive rolls that can weigh several tons. Forklifts and overhead cranes move them into position, and workers unroll the steel like you'd unwind ribbon. Only this ribbon could stop a truck. For the inner tub, strength and corrosion resistance are critical. This is where stainless steel shines. It's durable, gleams beautifully, and won't rust even after years of soaking in water and detergent. Meanwhile, aluminum arrives not as sheets, but in ingot form, solid blocks that look like oversized silver bars. These ingots are melted in roaring furnaces that can reach over 700 degrees Celsius. The molten aluminum is poured into precision molds to create complex parts like the transmission housing. Once cooled, these castings are cleaned and machined until they're smooth and exact. Then there's plastic, used for everything from the pump casing to tub guards and agitators. The process here is injection molding. The mold cools, the part hardens, and then it's ejected. Ever seen a washing machine shake, like it's trying to walk away? That's where the balance ring comes in. This is a deceptively simple but essential component. A heavy circular ring, plastic on the outside, metal or cement filled inside. It's carefully weighted so that during high-speed spins, it counters any imbalance in the drum's load. Without it, your washer could rattle, vibrate, and possibly even damage itself or your floor. Large sheets of steel are cut and fed into giant stamping presses, machines so powerful they can shape steel with a single thunderous strike. These presses form the outer cabinet panels, the drum body, and the reinforcing ribs. The drums are then rolled into cylinders, welded at the seams, and placed into spinning expanders that make them perfectly round. The edges are polished smooth, ensuring there are no burrs that could snag clothing later. From this point on, each piece is more than just material. It's becoming part of a precise system. The steel is no longer just steel, it's a cabinet wall. The aluminum is no longer just metal, it's the heart of a drive system. And those plastic parts? They're the channels and guards that will guide water, detergent, and clothing through countless wash cycles. The transformation from raw materials to functional parts is the first major leap in a washing machine's creation, and it's a leap that sets the tone for everything that follows. Without perfect materials and exact shaping, nothing else in the process will run smoothly. Once the raw materials have been shaped into their essential parts, the factory floor shifts gears, literally. This is where scattered steel panels, molded plastics, and machined aluminum pieces start becoming something more than just parts. They begin to form the beating heart of a washing machine. The process starts with the transmission, a crucial piece that sits between the motor and the drum, controlling how power is delivered during both the wash and spin cycles. Picture it as the gearbox of a car, only built to handle water, detergent, and constant starts and stops. Workers assemble this by bolting gears, shafts, and bearings together in a precise sequence. Everything must line up perfectly, one fraction of a millimeter off, and the machine might run noisy or fail prematurely. Once assembled, A carefully measured amount of special lubricating oil is added. This isn't just any oil. It's engineered to withstand the heat, friction, and occasional moisture inside a washer's life. Next comes the pump, the unsung hero responsible for moving water in and out of the tub. Some pumps are still assembled by skilled technicians, but many factories now use robotic precision. These robots insert impellers, seals, and casings together, with movements so exact they look almost alive. Depending on the design, pumps are sealed using heat or vibration welding, a process where parts are pressed together and vibrated at ultrasonic speeds until the friction melts them into one solid piece. No screws, no glue, just pure material bonding. Now the focus shifts to the tubs. Washing machines typically have two tubs, the inner tub, where your clothes go, and the outer tub, which holds water. The inner tub, especially if it's stainless steel, goes through a polishing process that leaves it shining like a mirror. Those tiny perforations in the sides aren't just random, they're carefully calculated to let water out while keeping clothes inside. For machines with porcelain-coated tubs, the process is different. First, the tub is given a porcelain ground coat, which provides a strong base layer. This layer is baked on at extreme temperatures to fuse it with the metal. Then comes the finish coat, which gives the tub its final color and adds extra corrosion protection. The result? A smooth, durable surface that can handle years of detergent, bleach, and hot water without chipping or rusting. As these sub-assemblies come together, you can feel the shift on the production floor. What was once just a pile of fabricated components is now starting to look like the working organs of a machine. It all begins with one of the washer's unsung heroes, the transmission. This component is essentially the muscle of the machine, converting motor power into the back and forth or rotational motion that actually moves your clothes through the wash water. The transmission is mounted securely onto the balance ring we talked about earlier, the weight that keeps the washer from turning into a hopping kangaroo during the spin cycle. Next comes the tub assembly, and this is a meticulous process. The outer tub isn't just dropped in, it's carefully fitted with bearings to reduce friction, a brake to control spin stopping, a pulley for belt-driven machines, and the pivot dome that helps support and stabilize the drum. Every one of these parts needs to be aligned perfectly, because even the tiniest misalignment can cause noise, vibration, or premature wear once the washer starts running at full speed. Once the tub module is built, it needs to meet its new home, the cabinet base. This is no simple lift and drop operation. These components are heavy, and a misstep could damage parts or injure workers. So factories use hydraulic lifts to hoist the entire transmission tub unit and lower it with millimeter precision into the base of the cabinet. From here, springs are attached to act as suspension, allowing the drum to move slightly during operation without shaking the whole machine. Seals are installed to keep water exactly where it belongs, and the agitator hub is mounted in preparation for the agitator itself, or, in the case of modern high-efficiency machines, the impeller plate. Now it's time to give this machine a heart, the motor and pump assembly. The pump is positioned to handle both filling and draining, and it's often shielded against leaks with protective covers or gaskets. Getting to certain parts for repairs can be a real challenge. Some manufacturers even run quick diagnostic spins or movement tests right here on the line to make sure nothing's binding or vibrating too much. Modern washing machine plants increasingly rely on robotic assembly lines to boost speed, maintain consistency, and minimize human error. In some cutting-edge facilities, an entire washer can be assembled in just 16 seconds. Yes, you heard that right. 16 seconds from bare frame to complete machine. The process runs like a perfectly choreographed dance. Robotic lifts position heavy modules. Precision welding units secure joints. Conveyor belts move parts at exactly the right pace, and camera vision systems ensure everything is aligned to the millimeter. Human operators are still there, but mostly to supervise and intervene if something goes off script. Once the assembly is complete, the machines aren't boxed up just yet. They face a rigorous series of tests: leak detection, spin balance checks, vibration control, and noise measurements both empty and loaded. Performance is assessed for water and energy efficiency, and some brands even simulate years of use in just hours. These steps ensure that when a washer finally reaches your home, it's not only ready to clean clothes, it's built to last and run safely for years. Take Whirlpool's Clyde, Ohio plant, a facility so vast it could fit 30 football fields inside. Winding through it are over 25 miles of conveyors, moving parts from one stage to the next in an unbroken flow. On peak days, this giant can produce up to 22,000 washing machines. But in a system this complex, even a tiny failure, a $150 coupling snapping, can bring everything to a halt. That's why the factory manager takes proactive measures, conducting twice-weekly Gemba walks to identify and fix problems before they snowball. His focus isn't just on output. Worker safety is part of the equation too. Here, efficiency and human well-being move hand in hand, ensuring production stays smooth and people stay safe. Modern washing machines aren't just more efficient, they're smarter and quieter than ever. Many now use direct drive BLDC motors, eliminating the need for belts and pulleys. Here's where things come full circle. From raw steel to a smart, spinning appliance, every site along this journey, fabrication, coating, assembly, testing, control units, is crucial. And each plays its part in ensuring your next laundry load gets cleaned safely and quietly. But what's next? Could robotic factories assemble washing machines without humans? Will smart washers die? Metal clangs, sparks flash, and in less time than it takes to choose a laundry cycle, raw steel and plastic parts come together into the comforting hum of your washing machine.